stresses. Okay, so we already know the strength. Okay, when we're talking about strength, it is the capacity of the beam to resist loads. Okay, it is just for resisting loads. How about when we say ductility? What is your idea about ductility? Raise your hand if you want to recite. What is your idea about ductility? No idea?
Ma'am, pag yung mga solid materials po nag-stretch under tensile po.
So it is the capacity of a member to what? Miss Tanagon?
To stretch, ma'am.
To stretch. Okay, so hindi siya agad-agad mapuputol. Okay, kasi stretch pa siya. Okay, so any other idea?
Ma'am, nade-deform po siya.
Capacity of
Deformation, yes.
Opo. Pero hindi po siya nabe-break.
Yes, okay. Correct. Any more idea? Yes, Mr. Tibangin?
Hindi ma'am, change shape ma'am.
Change shape. Okay, so it's not literally change shape kasi baka isipin nyo, yung beam natin mag-change ng shape. So it's not safe. Okay, so ano lang, pag nag-deform siya, magde-deflect siya, but it will not break easily or it will not collapse. Okay, so when we say ductility, it is the opposite of being a brittle material. Okay, so it's important to design a very ductile members instead of brittle one. Because if you are going to design it in strength only, but it will make the material brittle, so it will not be safe for the people that is inside the building because anytime that it cannot carry the load, it will suddenly collapse. Okay, so pag biglang nag-collapse yan, wala na. Patay na yung mga nasa loob ng building, right? But if your members are ductile, okay, so before yan mag-break, magkakaroon muna yan ng mga warning signs in terms of cracking. Okay, so unti-unti yung magka-crack hanggang sa hindi na niya makarry yung load, saka lang siya magko-collapse. So it will give enough time for the people to evacuate inside the building in terms of earthquake. Okay, so yung mga ganyan. So just bear in mind that if you are designing, you have to consider also the ductility of the members and also the toughness. So for introduction for shear, okay, so as I stated earlier, designer must produce ductile members that provide one warning for impending failures. Okay, so to achieve that, the code provides design shear values that have larger safety factors against shear failures than those provided for bending failures. Shear failures occur suddenly with little or no warning signs. Therefore, beams are designed to fail in bending under loads that are appreciably smaller than those that would cause shear failure. Okay, so ganun ka-importante si shear. Okay, kasi kahit malakas yung shear, yung capacity mo, yung strength mo, kung mahina sa siya shear, it will suddenly collapse. Okay, so what can you notice in the figure at the bottom? So what can you notice? The figure at the bottom. Nabiyak. Okay, so can you interpret the cracks of the beam? What can you notice?
unti-unti pong dumami.
Okay, isa lang. Sino nagsalta? Miss Valmejano?
Unti-unti pong lumaki, ma'am, tapos dumami po yung crack.
Saan siya dumami? Part?
Dun po sa malapit sa simula ng cracks lang din po.
Okay, so any more interpretation? What can you notice? Saan mas malaki yung cracks natin?
Sa may gitna po, ma'am.
Sa dulo po
Mas
ma'am.
marami yung crack sa gitna, pero mas malaki yung crack sa
Dulo po.
Dulo.
Support. Okay, sa support. Ano pa?
Sa support.
Ano pa mapapansin nyo sa cracks? Case, it is almost
Ma'am, hindi po siya parang hindi pa siya na masyadong na crack. Ay, yung kanya yung bibigay.
hindi pa siya masyadong bibigay. Pero technically, bumigay na to. Tignan mo, parang ito sa support niya, nag-break na to. It will not carry
May
more
support,
loads.
ma'am.
Oo, sa may support. Kasi pag once na nasira na siya dito, collapse na siya. Okay, so kita nyo ba yun dito? So, ang laki ng failure niya dito sa support. And as you can see, kung paano siya makrack, it's almost 45 degrees yung cracks niya. Okay? So, let's discuss more about shear failures at the next slides. At least you have an idea kung ano yung itsura pag shear failure. Okay, so you know that an elastic homogeneous beams have two kinds of stresses. These are the bending and the shear stresses. So the bending stress are already discussed in prelims and finals. Kaya natin dinidesign ang beams for the tension side, mostly at the tension side, right? Okay, so you already discussed it also, the formula for bending in shear in your strength of materials. Okay, so F is equal to MC over I and V is equal to VQ over IB. So we have two different kinds of stresses here. The principal stresses is the combination of bending and shear stresses into inclined compressive and tensile stresses, and the diagonal principal tensile stress, also called the diagonal tension, it occurs at different places and angles in concrete, and they must be carefully considered because if they reach certain values, additional reinforcing, that is the web reinforcing, must be supplied. Okay. So this look at the different shear cracks of reinforced concrete beams. Inclined cracks can develop in the webs of reinforced concrete beams either as extension of flexural cracks or occasionally as independent cracks. So it's very important that you know what type of cracks is happening in any structural members kasi it's as we discussed in prelims, shrinkage, creep, okay, so they are not critical. But if you see a crack in a concrete beam, yan, critical na yon. Okay, so especially if flexure shear crack yan. Okay, so when we are talking about flexure shear crack, look at the figure at the right. Okay, so ito yung example ng mga failure or flexure shear cracks natin. So these are ordinary types of shear cracks found in both pre-stress and non-pre-stress beams. For them to occur, the moment must be larger than the cracking moment and the shear must be rather large. So what can you see kung sa flexure shear crack? Nasa anong side ng beam?
Sa gitna po.
At the
Tension po.
Middle.
tension side. Yes, correct. That is in the tension side. Okay, so if it deflects at this manner, talagang dito yung magka-crack sa tension side. Okay? And it is very different for web shear cracks. Okay? It is sometimes occur in the webs of pre-stress sections, particularly those with large flanges and thin webs. These are inclined cracks that develop independently in a beam even though no flexure cracks are in that locality. So, hindi siya nag-start sa tension side, dito lang siya sa web shear cracks. Okay, so see the difference between the flexure shear crack and the web shear cracks. Okay, so ACI 11.5.1 discuss different types of stirrups. So we have an open stirrups and closed stirrups. It depends on your analysis. So not all members or not all structural members are carrying torsion. Okay, so depende yun sa location, depende yun sa connection. So if you're analyzing a beam with negligible torsion, you can design your stirrups in this manner from figure A to figure C. Okay, so ito yung mostly nating dinodrawing for stirrups, open stirrups. So take note that these are just for beams with negligible torsion. Okay, it can be in 90 degrees or pwede siyang mag-bend. Okay, and this is for I-beams. You can also do this in this manner and sa letter C. Okay, so saan ba nagba-vary kung anong design? Malalaman natin yan for the next discussions. In ACI 11.1.2.1, these are closed stirrups for beams with significant torsion. If your beam is carrying a torsion, you should design your stirrups in a manner that it is closed. Okay, just like in figure F and figure G. So in figure F, so these types of stirrups are not satisfactory for members designed for seismic forces. So if nagkicarry siya ng forces, hindi to pwede design ng stirrup. So what can you notice? Diba nag-overlap siya dito? But if you are going to do that, you should take note that it is not less than 1.3 LD. So your LD here is the development length. So meron tayong standard development length kasi hindi pwedeng masyadong maliit yung overlap niya. Hindi rin pwedeng sobrang close hanggang dito sa dulo. Hindi pwede yon. So meron lang tayong certain limit. And for figure F, I, and J, so these are concrete confinement on one side. So you can do this in this manner, or you can extend the bar, just like this one. Or you can do this if your concrete is confined in both sides. So at least you will have an idea what are the different types of stirrups. Okay, so let's move on to the design of shear. So we all know that in designing a moment, our basis for design is that VMN is greater than or equal to the ultimate moment. So we will do this also for shear. Okay, so this basis design for shear in a cross section is VVN should be greater than or equal to VU, where phi or the strength reduction factor is equal to 0.85 for NSCP 2001 and 0.75 for NSCP 2010. I think we still use 0.75 for 2015. You can check it in our NSCP. And Vn is the factored shear force at section considered. But take note that your nominal or factored shear force is composed of the nominal shear strength provided by the concrete, which is Vc, and the nominal shear strength provided by the shear reinforcement represented by Vs. Okay, so madali lang namang sandaan yung notations natin. Vc for concrete, Vs for the stirrups or the shear reinforcement. For shear strength provided by concrete, for non-pre-stressed concrete, so in order to compute for Vc, we have 1/6 square root of Fc prime BWD for 2001 NSCP and 0.17 lambda square root of Fc prime BWD for 2010 NSCP. So wala nang masyadong difference to because 1/6 is just 0.17. Nagkaroon lang tayo ng value of lambda for NSCP 2010. Where BW is the web width or diameter of circular section, D is the distance from the extreme compression fiber to centroid of longitudinal reinforcement. So we will use the same notations as we are using in prelims and midterms for the design of bending. And this is the calculation for simple calculation. If you are going to calculate the shear capacity or the shear strength of concrete in detailed manner, so you can use this formula. We have 0.17 lambda square root of FC prime plus 17 rho W BUD over MU multiplied by BW, and that should be less than or equal to 0.29 square root of FC prime BWD. Okay? Where lambda is 1 for normal density concrete. So we usually use normal density concrete unless specified in the design. Okay, so may mga cases kasi na kailangan natin ng light density concrete. So saka lang natin gagamitin yun. But usually we use normal density concrete. And take note that VUD over MU should be less than or equal to 1.0. So it should not exceed the value of 1. Okay, so do you have any question?
Ma'am, ano yung 1 doon?
Value?
Yung row W, ma'am.
Rho W. Still ratio.
Ay, okay.
Okay, so let's analyze more the beams with vertical stirrups. Okay, ba kapag nag-break ang isang member, diba ang beam, kapag kinat nyo dito, may lalabas na internal forces, shear, right? Hello? Correct? So, magkakaroon tayo ng internal forces. So, let's say the beam cracks in this manner. Hindi naman actually straight line ang crack natin eh. So, we're on 45 degrees. So, let's say the beam cracks in this manner. Magkakaroon tayo ngayon ng mga internal forces. Okay, so ano yung mga internal forces na mag-a-act dito sa beam natin? Can you please state one? Ano ba yung mga internal forces natin?
Tension po. T,
Tension,
yung T po, ma'am.
VCZ, VCZ, correct? Ano pa?
VD,
VD, yes. Okay, so we have VCZ plus VD plus, ano pa?
VIY.
VIY, yes. What else?
Compression.
P1 and P2, ma'am.
P1, P2 is not a forces, internal forces. So, magkakaroon din tayo ng force coming from the stirrup. Okay, so we call this VS, or we can just simply calculate this as AVFY, or the area of the reinforcement times the yield stress. So, plus VS. Okay, so these are the forces that act inside the beam. Okay, to simplify this, the shear force of the concrete comes from the shear force coming from the concrete plus the shear force coming from the shear reinforcement or the stirrups. And as stated here, VS is equal to AVFY, right? But this is just for one stirrup. So we don't know kung ilan yung stirrups, kaya let's just call this N for the number of stirrups. Okay? So for the shear capacity, of vertical stirrups,
Ay, vertical pala. So, yun.
so we know that Vs is equal to NAVFY. Okay? So, ano yung N natin? Okay, ilan ba yung shear reinforcement ng the brick? So, let's call this area. Check natin kung ano yung area na break to. So, from here hanggang dito, let's call this as P. Okay? And also, of course, this is your D, right? So, ano yung magiging value ngayon ng N natin? Paano malalaman kung ilan yung value ng N based from this length P? So, we can divide this length divided by the what? Paano ba kayo nagko-compute for number of bars? Saan tayo nagbe-base sa spacing, 'di ba? So, pwede na rin natin gawin yung dito. Okay? So, let N be P over the spacing. Okay? Pinalitan lang natin yung N as P over S times AVFY. Okay, so as stated earlier, the crux can be or almost 45 degrees from the horizontal. So let's say that our theta here is almost 45 degrees. So therefore, the value of your P is equal to kung 45 degrees to, ano yung magiging value ng P? Equal to 30 half. Is your P. This is your D. Therefore, P is equal to terms of depth. Kasi mahirap naman natin makuha to. Okay, so paano natin makukuha yan? I-measure natin yung length. Pero in reality, mahirap yun. So we just compute the vertical stirrups or the shear capacity of stirrups in terms of depth. Kasi yung depth, madali natin makukuha yon. So D over S, AV, FY. So ito yung gagamitin natin for the shear capacity from the stirrups or shear strength from the stirrups. Okay? So how about for the nominal strength? So that is just for the shear strength. How about for the nominal strength Vn? So we know that Vn is equal to Vc plus Vs. But Vc coming from here is equal to AV Fy D over S. Okay? Okay, so this is the shear capacity of the beam. or pi over 4 diameter squared? Yun lang ba yun? What do you think? So, is AB equal to area of bar? Hello?
Ma'am.
Yes? Is it, ano?
I-minus yung one, ma'am.
I-minus ang alin?
Yung cross-sectional area ng beam. Tapos yung area ng steel.
No, not really. We're talking here about the area of the vertical stirrups itself. Okay, so if you have a force here, ano ang nagre-resist? Is it the main reinforcement or the stirrups?
Yung main po, ma'am.
Main? Are you sure?
Parehas, ma'am.
Okay, so for the stirrups also, ano yung magiging area ng stirrups na magre-resist dyan sa load na yan?
Yung vertical, ma'am.
Vertical. So, is it just pi over 4d squared?
Times 2.
Times 2, correct. Bakit times 2?
Dalawa po, ma'am.
Okay, so look at this. This is considered as the legs, the stirrups, of the beam, okay? Kasi para siyang... So, dalawa to ang nagre-resist sa load mo. So, you have to multiply it by 2. But take note that it is not always 2. Why? Look at the types of stirrups. So, here, alan ang magre-resist? Dalawa, di ba? How about for D? Ilan ang magre-resist?
Apat po.
Apat. How about for C?
Apat din po.
Apat din. Yes, correct. So, nakukuha nyo ba yung logic kung paano kunin yung area of shear reinforcement?
Yes, ma'am.
Okay, so it's not always 2 ha, but syempre for theoretical purposes, we usually use this type of stirrup, kaya laging 2 ito. Okay? And also, you know that Fy is the yield stress. Okay, so do you have any question?
Ma'am, yung area of shear 2 times number
Area of
ay
bar.
area ng bar.
Oo.
Ma'am, yung one ngayon. Spacing.
Is
Ano mo war?
spacing. So, yun yung i-design natin for shear. Let's
Ay, okay.
discuss it later. Okay?
Ma'am,
So, yes.
yung area,
Ano yan?
yung sa area of bar niya, ma'am, yung stirrup ba na ang bar yung pan?
Yes,
Gagamitin.
stirrup of bar. Kasi ito yung nagre-resist eh. So, area ng stirrups ang kukunin nyo dun. Diba, it's either D10 or D12 lang to. Okay?
Yes, ma'am.
Okay, so do you have any more question? Clarification? None?
Ma'am, yung ano po, yung paano naging equals to dito?
P is equals to D because we said that the area or the angle of the crack is 45. But take note that it is not always 45. Pwede nyo yung i-compute. Pero syempre, for simpler calculation, we assume that the P or the angle between P and D is 45 degrees. For simpler calculation. Okay?
Ma'am, yung VC po ngayon, ano po yung VC?
VC has stated here that VC is the nominal shear strength provided by the concrete.
Sige po, ma'am. Sige po, ma'am.
Kasi tatandaan nyo, sa shear, composed of concrete tsaka shear reinforcement yan. So let's proceed to the design of beams. Okay, so before we move on to the different cases, let's talk about design. So in terms of design, we know that the ultimate shear should be less than or equal to PVN. Okay, where Phi here is equal to 0.75 according to NSCP 2010. VU less than or equal to Phi Vn, and Vn, we all know that Vn is composed of the shear strength coming from the concrete and shear strength coming from the shear reinforcement. Okay? Kung isa-substitute natin to, PVC plus PVS. And we already derived the formula for Vs a while ago, that it is AV FY D over S. Yes? Question?
Okay na.
Okay.
Di lang nalagyan po ng fee yung isa, yung VS.
Okay. Thank you. Okay, so itong VC kanina, pinakita ko na yung formula nito ha, yung detailed and simple computation. Okay, and we already derived the formula for shear reinforcement. So, ano yung magiging basis natin ngayon for the design and analysis? Okay, so I'll state a scenario and kayong mag-decide. What if your VU ultimate shear is greater than the shear of your concrete? Do we need a stirrup or not?
Hindi na po, ma'am.
Why?
Kasi mas mataas yung VU, ma'am.
Ano ba yung VU natin?
Ultimate shear, ma'am.
Ultimate shear. Okay, so what is PC?
Nominal shear strength.
Of concrete. Okay, so it turns out that your ultimate shear is greater than the nominal shear strength of your concrete. So do you need a stirrups or not?
Hindi na, ma'am.
Are you sure? Diba?
Ma'am,
Pag
kailangan-
MU yan, greater than VMN, is it safe or not? Safe ba yan? Hindi. Diba, VMN should always be greater than or equal to MU. Kasi itong, pag sinabi yung MU, VU, that is the ultimate shear or moment that will be experienced by the beam. So if it turns out that your ultimate shear na ma-experience ng beam mo is more than your capacity, it means failed yan, di ba? So kailangan ba natin ng stirrup o hindi? Kailangan natin ng stirrups because the concrete alone cannot resist the ultimate shear. Did you get it? Hindi niya kayang buhatin. Okay, kasi mas mataas yung ultimate mo eh. This is your actual, this is the required capacity. So, mas mataas yung actual mo dun sa capacity mo. Okay, so dapat magdagdag pa tayo ng shear. Okay, so if VU, okay, so your ultimate shear is less than the capacity of your concrete, kailangan ba natin ng stirrups or hindi? Hindi na. Kasi, bakit hindi na? Okay, so can I explain kung bakit hindi na natin kaya?
Abot na po yung mas mataas na po. Mas mataas na po yung kaya average tayo yung complete po ng pagkakao.
Okay, so mas mataas na yung kayang-kaya na lang buhatin mag-isa. Kumbaga, si concrete, kaya-kaya na buhatin si ultimate moment, kaya hindi niya na kailangan ng tulong. Dito, nagigets nyo ba naiintindihan nyo ba yung importance ni stirrups when it comes to shear strength? Yes, okay, so very good. Okay, so let's take a simple beam here. Okay, so let's load this WU. Okay, magkakaroon tayo ngayon ng reaction sa left side and the reaction sa right side. Okay, when it comes to flexure or bending, nagbe-base tayo sa ultimate moment, which is at the center. Correct? Yes. That's why, ang design natin is always sa middle. Kasi yun yung critical. Because kapag nag-bend siya in this manner, ito yung critical, di ba? Compression and tension. Dito naka-base, bakit yung beam natin is this is the compression side and this is the tension side. And we always design it critically at the tension side. Okay, so it is based on the moment diagram. Okay, if you know how to draw a shear and moment diagram, you know how to analyze a beam properly. Kasi base lang yan lahat sa shear diagram, moment diagram, deflection, kaya wag niyong kakalimutan yung theory of structures nyo. Okay? That is very important. How about for shear? So, paano ba yung shear nito? So, this is based on the reaction. Okay, so, pretend this is equal kasi uniform load lang to. So, RL is your ultimate shear. Tama ba? Tama ba? Yes. Okay? So, balikan natin yung picture dito. Saan na nga ulit ang ultimate shear? I mean, saan na nga ulit siya mas malaki yung crack?
Sa support po.
Sa support. Okay, so look at the shear diagram. Saan mas malaki yung shear?
Sa may support po.
Sa may support. So, we can conclude from that at the support, the shear is very critical. Okay, kasi nandun yung maximum shear natin. Pag sa moment, critical tayo sa gitna because nasa gitna yung maximum moment natin. Okay? Ito yung maximum moment natin. While for shear, zero shear tayo sa gitna. Kaya magpo-focus tayo dito sa maximum shear capacity or strength, which is at the support. Okay, so kung mapapansin nyo, that is just based on your shear and moment diagram. Right?
Ma'am,
Yung design nila, yes.
paano pag mas mataas yung sa kabilang support? Yung sa may negative.
If hindi siya uniform, possible yun.
Yes, ma'am.
Kasi ito uniform load to kaya talagang equal siya. Okay, pag nagkataon na meron kang mga additional loads dito, or dito, or dito, syempre, i-compute mo yung talagang maximum shear niya.
Okay, ma'am.
Okay? So, also, hindi laging simple din yan. Okay? Diba, meron din tayong cantilever. Okay, so sa cantilever, saan yung maximum moment? Saan ang maximum moment ang cantilever? Maximum moment? Hala, hindi siya alam. Saan ang maximum moment pag cantilever? Hindi nyo ba napag-aralan to? Hello?
Kalimutan na po.
Nakalimutan na. Oh my gosh. Sa? O sige, sabihin natin. form yan? O saan?
Doon po sa may support, ma'am.
Oo, sa nakakurong moment. Saang dulo? Sa free end ba o dun sa strained? Oh my God.
Hindi na maayos yan.
Totoo ba?
Feeling ko sa
Grabe.
may ano, ma'am, sa may ano,
Walang kanto, walang support.
Sa may walang support, yun ang maximum moment.
sa may
Sa
support
may
po.
joint mo.
Sa may... Wala kayo. Nakaka-bother ka. My
Ma'am,
gosh.
promise walang explanation dyan.
Ano wala explanation? Okay, paano to? Saan yung
Hindi na i-ano
reactions?
sa amin.
Saan ang reactions dito? Meron tayong vertical. Okay? Horizontal. At
Moment.
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 O, wala namang moment dito. So, nasa
Sa
yung
support.
maximum moment.
Support.
Nasa support.
Choice.
Okay. Okay? So, ibalikan nyo yung theory nyo, promise. Ika-explain ko dito ha, kasi dapat na-explain na yan sa inyo. And pero it's better if you really understand how it works. Just like here, simple being, very common na yan. Pero pagdating sa board exam, and in real life, or in your actual work, it's not always simple being. So, huwag kayong mag-stick sa knowledge nyo na simple being lang. Dapat alam nyo rin yung iba't ibang kind of beams. Okay, so we have fixed. Okay, so hindi lang laging fixed yan. Meron pang fixed at one end. Simply supported dito. Okay? So, aralin nyo yun, ha? Paano kapag magbigay ako sa exam? Cantilever. Parang masaya. Okay, so balikan nyo yan. So, ang gusto ko lang iparating sa inyo dito is the analysis and designs of beams are just based on your shear and moment diagram. And also sa deflection nyo. Okay? Kasi di ba sa lecture, kung paano yung deflection niya, doon tayo nagpipase o compression, tension. Dito sa support, tension, compression. Okay? So, ganun yun. Kailangan yung maintindihan nyo. Dapat isang sem lang ba yung theory nyo?
Yes, ma'am.
Kasi dapat dalawang sem yun. Theory 1, theory 2.
Ma'am, andun na lahat.
Hindi yun may tuturo.
Pinagsama-sama.
Hindi nyo yun matatapos ng isang sem.
Iba kasi ko na
Kaya
ganun,
doon
ma'am.
kami nakalahat, ma'am.
Oo,
Narush
ma'am.
lang kami doon.
Tapos pandemic pa. Sana.
Ano? Tapos, online pa. Okay, so,
Online pa.
okay, so, gawin
Wala
pa
pang
tayo.
tunay.
But, kaya meron yung mga textbooks. Okay, so, don't just depend on your instructors. Kasi it's for your own good din. Sa board exam, mawibindang na lang kayo, ay, hindi naturo sa amin to. Ay, hindi naturo sa amin yung ganito. Pero, kung inaral nyo din on your own, you did your part, at least magkakaroon kayo ng idea. Okay, so, huwag kayong mag-aral para lang pumasa sa isang sem or sa isang subject. Ang gawin nyo is mag-aral kayo para makagain kayo ng knowledge so that you will not only pass the subject, you will not only pass the sem, okay, you will graduate on time and you will pass the board exam. Okay, so yun yung maging motivation nyo to study. Okay, help yourself. Okay, so yun na. Okay, so let's continue. I-delete ko na itong moment. So, for the speed ups required, than VBC, di ba? If VU is greater than VBC, the stirrups are required. So how can we know the spacing? Okay, so yun yung tanong ninyo kanina, Mr. Gumangan ba?
Yes, ma'am.
Okay. Nagbibis lang ako sa boses, hindi ko kasi kayo nakikita. Okay? So, we know that VVS is equal to V AVFY D over S. Okay, so transform lang natin to. We can get the value of S by i-substitute nyo lang dito. Pag interchange nyo lang. So, AVFY D over
Theta
EVS. Okay? Ano naman na yun yung magiging value ng VVS natin?
VU minus VBC.
Yes, correct. So, VU minus VBC. So, kung ano lang yung hindi kayang i-hold ni concrete, yun lang yung ipapasa niya kay stirrups.
Ma'am,
Yes.
i-cancel na po yung mga cable.
Pwede naman kasi same naman yung value niya. Okay. Kaya lang, kasi mag-iiba tayo ng value. Diba? VVS is equal to VU minus VBC. So, if we do that, VAVFYD is or over VU minus VBC. Ayan. Okay, so mas maganda kung hindi nyo i-cancel. I-substitute nyo na lang kung ano yung value ng VVS. Okay? So, let's move on to the 4 cases in the design and analysis of stirrups. So, the first case is that if your VU is less than your VBC, okay, so your VU is less than your VBC, and your VU is 1/2 VBC. So, kung magtataka kayo, itong half of VBC natin is just your limiting factor or limits. Dito kasi tayo nagbe-base ng mga spacing, kung hanggang saan yung ganitong spacing. So, ito yung magiging limits natin. Okay, so this is based on codes. I don't know kung paano nila nakuha to, but mostly, ang codes kasi, paano ba nila nakukuha yung mga formula doon? That is based on experiments. Okay, so nag-experiment sila from the empirical, gumagawa sila ng theory. And then, they can formulate yung mga ginagamit nating formula from code. Okay, so itong mga to, na-derive na nila to, na-formulate na nila to. So, ang gagawin na lang natin is to adopt it. Unless gusto nyo gumawa ng sarili nyong formula. Okay, so you have to experiment. Okay, so for case 1, kailangan ba natin ng stirrups or hindi? Hindi na. Okay, so if this is your VU max, and this is, okay, so for case 1, web reinforcement is not required. Okay, so this is your X. Kung uniform load, it is just L over 2. Okay, so hanggang dito lang yung ina-analyze natin. So that is for case 1 and your VU is less than half of VBC. How about for case 2? Your VU is less than VBC, so technically, hindi required ang stirrups natin. But take note that your VU is greater than half of VBC. So kanina kasi,
Mid pa rin mo.
less than siya sa PVC, ngayon naman, half of PVC. So, for example, this is your VU max. Take note that it is less than your PVC. Okay? But this is more than half of PVC. So, if this is your 1/2 PVC, okay, so if this the VU at this part is half of PVC. Ayan, so kung mapapansin nyo, if this length is x, let's call the area x2, and this is x minus x2. Okay? But what can you notice at this area?
Triangle po siya, ma'am.
Yes, but your VU here is less than PVC and your VU is less than half, diba? If dito yung 1/2 PVC nyo, itong mga values nyo dito is less than half of PVC. Therefore, at this area, anong case to? Case 1, diba? Your VU is less than PVC and it is less than half of PVC. Okay, so less than half of PVC siya at this area. Therefore, ano yung magiging web reinforcement natin dito? Ano yung magiging web reinforcement natin? Required? Diba case 1 to?
Not required.
Not required po,
Okay,
ma'am.
so at this area, web reinforcement, maano ba? Malight ba?
Okay lang, ma'am.
Okay lang.
Sakto lang naman, ma'am.
Okay, so so at this area, web reinforcement is not required. Kasi it falls under case 1. Okay? Pero dito sa area na to, greater than, okay, so take note that it is greater than PVC. So if that's the case, magkakaroon tayo ngayon ng minimum area of reinforcement is required. Okay? So kung ganito yung beam nyo, dito lang kayo sa at x2 distance, dun lang kayo maglalagay ng minimum area of reinforcement, but from x minus x2 distance, hindi na kailangan ng reinforcement. Okay, so pag na-analyze nyo kasi to, mirror lang siya dito, di ba? Kung ganito yung setup nyo, uniform load, pag na-analyze nyo to, it is just a mirror at the other side. Okay? So, sundan nyo lang muna to. Basta ang magiging limit natin dito is yung 1/2 PVC. Let's move on to case 3. Here, case 3 is VU is greater than PVC. So, what does it mean? Yes, so stirrups are required. Okay? And PVC is equal to C square 0.33 square root of FC prime dW. So take note that it is just for the limits. Okay, so limits lang ito. Okay, so let's analyze this problem. Okay, so or this case. This distance is x. Okay? This is x over 2. And this is x minus x over 2 if, diba dito yung half natin, VU is equal to half of VBC. Paras lang to sa case 2. Tama? Half of VBC. Ngayon, if this is your half of VBC and this is your VBC, magkakaroon tayo ngayon ng another region here. Let's call this x1 and this area in this length is x2 minus x1. Susundan? Okay, so this is your VU max and it is greater than VBC. Nakikita nyo naman sa graph that it is greater than VBC, right? Okay, so let's analyze this area. What is this case?
Case 1.
Case 1, where web reinforcement is not required because the value of your shear is less than half of VBC. Web reinforcement is not required. Okay? So let's use another pen. How about for this area? Anong case to? Ang limit niya, VBC to half of VBC, therefore greater than siya sa VBC. And your VU here is less than VBC. So for example, ito yung VU nyo. Diba? It is less than VBC, but VU is greater than half of VBC. Nasusundan ba? Tingnan nyo yung limit nyo. Okay? So, anong case to?
Case 2.
Case 2. Okay? Where, ano yung magiging syrups natin dito? A, B minimum. Based on case 2, diba? Nasusundan ba? Okay, diba? So, greater than siya sa half of VBC, pero less than siya ng VBC. Therefore, AB minimum is required. Okay, so let's move on to the next. At distance x1. Okay, itong naka-red na hatch dito. Okay, ang VU mo dito is greater than VBC. Therefore,